This conference will now be recorded.
Well, thank you, Elena. Thank you, Eddie. And thanks to the Young Professionals Community of Interest. Glad to be back again speaking to you. Up on the screen, our title for today, Digital Twins, Successfully Leveraging Data for Maintaining Facilities and Infrastructure. And a lot of this is based on the work that Walter did while he was with us as an EWE, Education with Industry Fellow. And he'll explain that in just a brief second, but wanted to frame what everyone is here for today. Also showing the next slide, which is our detailed description about digital twins. I think this is all from the what I'll call marketing material to try to draw you in and focus on the importance of where we see digital twins, at least in our business, as well as some reference from the necessity based on maintenance within departments of defense and the ability to really make an influence in the federal space, given what we're able to do with the concept behind and action of enabling digital twins, which we'll explain as we walk through the slide deck today. We've got 4 objectives, which I think we will easily achieve. As Elena mentioned, as you do have questions, feel free to pop them into the chat throughout the duration. Eddie and Elena will be monitoring, as well as Walter and myself, so that we can provide cover on those questions. And certainly at the end, we will reserve time for more structured Q&A. Objective 1 is to define digital twins. Objective 2 is to understand the difference between digital twins and building information models or modeling. 4 is what are the benefits and challenges, and then 5 are next steps. This is meant to be a fairly high-level presentation. We do have a few, I guess, technical examples as we walk through it. So hopefully we'll give you just a small dive down into the weeds. With that, I'll turn it over to my co-presenter. If you would like to introduce yourself, please.
All right, appreciate it, Kurt. Thank you for that wonderful description of digital twins, as well as the objectives that we'll be walking through today. Well, I see a few familiar names on the chat, but just in general, I'm Walter Lee, Mr. Walter Lee. I'm a civil engineer group installation planner, community planner at the time, and responsible for 11 different tenants and doing some, enterprise objectives as far as planning is concerned. But I wanted to talk more in relationship to the education with industry and what I just accomplished with the program here that was about 10 months to a year long. And what AFIT does, it puts it on with the Secretary of the Air Force, and together they jointly provide this opportunity for 70 plus, it could be even up to 80 personnel to take some time out from their active duty or civilian service and take a little time with industry. And essentially what this is designed to do is designed to give the civilian or the active duty member a little bit more ideology and understanding as to how industry works. And at the same time, it provides industry an opportunity to understand a little bit about how DoD works and some of the vernacular that's a lot of times utilized. So in doing all that, the main goal for EWE, in this case, education with industry, as you see it here on the slide, is to develop Air Force leaders with a greater business acumen and empathy. And you can read the rest of it. But the key is just to get that expertise to be able to come back to the Air Force and implement change or for process down or proceed down the process improvement activities that require of change management. And I also say this too as well. It's one of the greatest programs that most people probably don't know much about, and anyone can do it, active duty or civilians. And a lot of times the civilians don't really know too much about how the program works. But I just encourage you, if it's something that you want to get into, it can be Jacobs, it can be with General Electric, it can be with any company in general. And it's just a phenomenal opportunity just to be able to work, especially in my consideration here with Jacobs and Kurt and his team. It's a phenomenal opportunity to work with them to learn and understand how they do their processes and how things are set up and how those objectives are met and how they're meeting the DoD mission and providing that assurance. So with that, I'll want to give a shout out to Aggie Pride. Any Aggies out there, I always got to give a quick shout out. But other than that, that pretty much explains it there. So I'm ready for the next one. Be ready, Kurt.
Yes, sir. Thank you. And appreciate having the opportunity to have you and Captain Gillette join us for like you said, about a 10-month tour with Jacobs. We're a proud supporter of the EWE program. And as many of you know, we have a number of fellows in our ranks at Jacobs, and part of that is giving back. And they've kind of trickled that down to those of us that haven't been in the society as long, and glad to be associated with the EWE program, and really glad, Walter, to give you the opportunity to showcase some of the great work that you did with us last year. So for myself, Kurt Moldovan, I'm based in Arlington, Virginia. I'm our Global Solutions Director for Digital Delivery, and I'll explain what that means in a few slides. But I did want to just take the time to also say that I've been around SAME for a good while with the Washington, D.C. Post, nearly my entire tenure. I'm part of the board, our membership chair, as well as a former young professional, kind of graduated out of that program not too long ago, but proud to be back presenting to this group. Won't touch too much on the details of digital delivery, but there is a close tie between our digital market and digital delivery, building information modeling, and digital twins. So with that, we'll touch on a few applications and benefits before we get into the further process, if you will. So with that, our first slide gets into what is a digital twin. So from my perspective, and this is a definition that Jacobs had spent a good bit of time massaging and developing. There are many different definitions, as you'll hear from industry, around digital twins. And we decided it was important for us to really take stock of what digital twins meant to us, having our own internally developed solution for over 10 years. We stopped and we went deep, and we had a working group that provided the definitions that are up on the screen. So from our perspective, it's connected digital representation of physical systems that unite the real-time data, simulation, analytics, and visualization to support both human and autonomous decision-making. And we added a second component, which is the physical system, which is the real-world elements, equipment, in which the digital twin is based off of. So there's a physical component that has a digital replica, a digital twin. The physical system represents an asset, a process, a system at any stage in the life cycle, and it can vary depending upon what the system or tool or piece of equipment is. So I want to frame that, and hopefully that helps answer the question, what is a digital twin? I think there's a little bit better description, or at least some more details, that I'll share on the next slide. So just a bit of promotional material with respect to digital twins and Jacobs environment. Walter, I'll turn it back over to you to walk through the insights piece.
Okay, thanks again, Kurt. Yeah, just for the group here, we're just going to talk just briefly at a high level about the general digital twin insight. What you see here, in particular, I'll talk to the picture here, is you see this physical asset, which, is colorful with all, but the key is to focus on the different components. Like you have a light bulb, you got the electrical, hazard symbol, you have data-driven analysis. You see all these different symbols here, and what the idea behind showing this is like it's disproportionate. So let's say for a physical asset that we can pick a mechanical system, electrical system, a generator system, whatever. The asset may not always necessarily be optimized, right, for our ability to utilize it for decision making. So what Kurt alluded to earlier, we have this physical asset and we want to turn it into a virtual asset, and that's essentially what digital twinning is doing. But the key component behind it is the decision making piece. So as you see the physical asset turning more toward the virtual asset, some things are required, or some things are unique to transforming that asset into a virtual asset. And some of the things you need, and Kurt will talk more in detail too later, it's about that common data environment or that repository. And you need, and I would suggest or recommend, highly recommend model managers or data folks with data analysis background to be able to take the data from that physical asset or the data that you want to, in this case, garner and provide for the virtual asset, do that telemetry component piece that you see there on the bottom right. Sensors and other data is also important. So the key is you just finding out what that data is and how you're going to incorporate that data and what you really want to do as far as your requirement. And I think that also another component there, which isn't really mentioned a lot, but will, it's kind of mentioned in a lot of the research, is this whole machine learning, artificial intelligence piece that gives you the opportunity to go back and forth, where you kind of remove the human component for a bit. But just looking at some of those requirements, just like I said before, and the key thing is it's a model, right? So there's use to it. You have to figure out what that use is. You have to understand what that requirement is in order to figure out what that use is. But it doesn't mean anything to the human if you can't see it. So that data visualization piece, and that component, that telemetry component, is critical. It's key. It's like your BMW or your expensive car. It's got all these different gadgets and things and onboard systems. The car that is doing things, it's making noises, it's providing input, but you can't see it unless you have some way to see it, and that's what that data visualization is. So just want to just kind of walk through that a little bit, and that concludes this slide here.
Yeah, I'll just add to that, Walter, that the human-computer interaction piece is still very paramount. You mentioned the ML, machine learning, and artificial intelligence, which is kind of the behind-the-scenes running, if you will, of the digital twin. And you alluded to the transition in many senses between what does a facility manager or operator do today and what their role will be in the future. And so while those are aiding the decision-making process, there's still that human-computer interaction that's required today as digital twins gain adoption and awareness. Taking a sidestep, I did want to make sure that we touched on BIM, because one of the objectives is to understand the difference between BIM, building information model, or modeling, the act of, versus digital twins. And according to NIBS, this is the long-founded definition that they came up with at NIBS in 2012. It's a digital representation of a physical and functional characteristics of a facility. And you can see that there's many parallels between this definition and the definition of digital twins. It has the physical, the environment piece, and the functional, right? What is the real performance? And so when we started implementing BIM 15 plus years ago, we had the idea that it was almost that digital replica. Little did we know that in 2020s, there would be the ability to tie two sensors and to really understand the actual performance of pieces of equipment, as you can see, pumps, piping, etc., that's on the screen, that really understand the way that a facility works. So there's a parallel, there's a complement. The next slide talks more in DoD speak. Some of you may be familiar with the CAD BIM Center. There's also the link to the whole building design guide, which gives some references between FCAC. Really just wanted to share this as a series of resources, because the ECB guides you to what requirements are out there from a BIM standpoint in the DoD space. It talks about other requirements in the UFGS. And then the CAD BIM Center is a host of information and resources, even including Revit templates, model templates, content. It gives you the guide on how to create that building information model. Wanted to also pause and explain what does digital delivery mean, because that's close to my heart. As a practitioner for a number of years within the Jacobs business, we've redefined, we've gone outside of the norm of building information modeling and started to define things that are more appropriate to the markets that we work in. So vertical information modeling represents our built environment. Linear information modeling represents transportation, rail, highways. Plant information modeling is our water treatment, wastewater, and even some high-tech type facilities. We have virtual and augmented reality, automated design, which is again more human-computer processes, and robotic process automation, which is looking at using computer bots to run processes for you. As a whole, these are all leading to the use and application and effective use of products for more efficient and automated delivery. That's one of our end goals through digital delivery. And the complement is within digital twinning. How do we leverage that model information, model data to feed into digital twin? Walter, I'll give this one over back to you.
Okay, before I start, I will add on to what you was making statements about the BIM and the digital delivery. BIM has the capability to do things that a lot of people probably do not know much about, all these different dimensions that it's capable of doing as far as schedule costs and some other facility maintenance and construction maintenance and management opportunities there with BIM. And it's really close to becoming, if it's not already considered in some cases, a digital twin or replica of some sort. I mean, you could utilize that. It could potentially be that replica for the digital twin, or it can be tied in as a digital twin. It just depends on, because it's that common data environment again, that repository that this provides for us to put all your different data in, like what Kurt was mentioning earlier with the augmented reality and the virtual reality, and then some of that geospatial data. That can be possessed and placed into the BIM and utilized in that manner, just as a repository for all that data. And that's a key component. But moving forward, I'll mention this slide here of the digital twin, the need for digital twins. And we were making statements earlier. It provides these insights. There's insights into the physical asset that you won't necessarily be able to determine by just looking at it or working on it or maintaining it. Sometimes you need another way, another venue, another viewpoint of that asset. In this case, that virtual viewpoint. It provides some of the interventions and outcomes, right? These are components that's all provided from digital twin. And as I mentioned before, that key thing with the whole digital twin idea is that whole decision-making piece. It's designed to help you for the further decision-making, real-time decision-making. And in some cases, it even aids the human in the decision-making continuum. Everybody's familiar with this whole OODA loop thing, right? In the military, the decision-making process. But this digital twin component can aid that and enhance that and facilitate that and improve it. And I want to make this little comment here that's on the slide here. Digital twin communicates and visualizes insights, again, to provide that data-driven decision making. And I want you to take that to heart. I want that to stick with you, that data-driven decision making. That is key right there to the whole entire digital twin component. Now, all these different things are great, but the key, again, data-driven decision making. And that's all I have on this one here, sir. Well, moving into the general processes for creating a digital twin. Now we're going to get into a little bit of the meat here. And I want to take your attention to the graphic here. And I'll walk you through it. We'll walk you through it left to right, looking at the red box, broken box, gray, green, and all the other components here. But the key in doing this is you have something what you want to call steps in the gray box here, but I'll walk you through it. So the physical asset is this red box here. Just taking a box because people are used to seeing boxes, understand boxes in 3 dimensions. But within that box are all these different data components, right? Electrical data, camera data, visual data, Wi-Fi, right? Computers, and a lot of other different types of Excel data. But see, that thing is just a conglomerate. It's just in the box. It's all over the box. You don't really know what you're doing. You got all this different data. You don't know what to do with it. So then what you want to do, you got to determine those initial requirements. And you're going to break that box open, right? You're going to break it open. You're going to take those different assets that's in that physical asset, the data-driven piece of it. And you're going to optimize or reorganize that data. You're only going to take the data that you want to utilize for the decision-making continuum or that process. But the way to do that is, again, what we talked about before with the managers, the model managers, the data managers, the folks that's seeing this, the analytics, and has the analysis background, that ability to incorporate these different things and to see what that data and what the data is that you need, right? So once all that is taking place, you get in the data, you got model managers helping you organize the data, then you move into this continuum we call the virtual asset, is the replica. And as you see the arrows there going right and left, it's a relationship. It's going back and forth. It's a continuum. It's a OODA loop, if you want to call it. back and forth, providing information from the physical asset to the virtual asset, physical asset to the virtual asset. And this is done with machine learning personnel, right, or artificial intelligence. But humans, personnel can do it as well. It just may take a little bit longer and more effort. But again, like I said before, once you replicate that thing, right, you replicate that asset, it means nothing to you unless you can see what the output is. So that telemetry, that's the computer, that's the visual, that's the HMI, human machine interface. That's those components right there that's needed. That's your BMW with that onboard computer that's telling you when to take it in and how much money they're going to charge you. That's what that is. So I want you to focus and understand that process. And that's all this graphic is showing. It's just showing the process from left to right of how this physical asset can be broken up, turn into optimized, turn into a virtual replica asset, and then that telemetry provided. That is the key. And then machine learning and AI just help to automate those processes and create connection. That's the key right there. And those are the items I wanted to point out on this slide here. Over.
Yeah, I'll just add one item to this, Walter, because you've made it sound rather simplistic in some senses, and that's not a bad thing. Just having been part of some of these discussions, there's a lot of upfront conversation that goes into how do we even classify assets? How do we know what naming is in a very simplistic sense? How do we have that library of content so that we can easily create the digital twin? Those are all discussions that need to happen at the beginning, because it sounds like, and I do have a question for you at the end, if nobody answers it or asks it, is related to how to get started. And again, it's an enterprise approach in many senses, that it takes a little time to really dive into what are those types of things, what are those physical assets that you want to be able to track and monitor and gain performance on, that will help you at the end of the day. So I'll move on to the next one, which is also your slide, Walter.
Roger that. Okay, now this is where it's going to get interesting now. Now these are some of this data we talked a little bit about it in the beginning with the BIM and how it can be utilized as a data repository and also as a minor digital twin. But now we get into some of the data and some of the things that's common to Air Force or Army or Navy or Coast Guard Marine engineers, right? Is this whole idea about you have AutoCAD data, there's plenty of it. There's facility cost data, as-built data, right? There's GIS data, GPS data, there's satellite imagery in some cases, depending on what you're working on. There's physics-based modeling. There's these, what we call builder, sustainment management systems, next-gen IT, right? That's a big deal. All these, and then let me go into this facility-related control systems too. Some of the systems can be utilized. So all these inputs, right? It's all this data. A lot of people, I'm sure, have been asked or will be asked at some point in the future. Hey, we need to do. We got this asset in this facility. We need to find out, when it's dated or when it's dated. How are we gonna replace it? We got to write the 1391. We need to get the information for that, right? But we got to go through this whole process, talking to real property. We're talking to all these different components, planning. The folks downstairs in construction management, the folks in the operations is doing the maintenance on the facilities and those systems to get this data. What if it was in a centralized location and we could utilize that data and for decision making purposes real time and quickly versus having to spend your day or week pulling the data together? So that's what this whole cloud thing comes into. It doesn't have to be BIM. It could be a system that has authorizations, appropriate authorizations for those that's requiring or needing to know for that data, depending on what that data is and what the classification of that data is. Right. And then again, like I said before, I mentioned it in the last couple of slides, the human machine interface, that is the critical component. Means nothing if you can't see it. And I think those are the key things here. But that's what this slide is showing. It's showing it supplementing existing and new data. You have this data. A lot of this data you already have. But sometimes there might be gaps, right? So the gaps, that's what we use, particularly in the Jacobs research. They utilize a lot of machine learning and even some statistical analysis, regression analysis, to upfront build model building to extrapolate some of that, or in this case, extrapolate some of that data and fill in the holes. So it just depends. But I just wanted to touch on that a little bit here, Mr. Kurt. Thank you, sir.
Yeah, and the only thing I'll add is that data is imperative, because as you just said, once you collect that data, then you can get historic information on that. And one of our examples is related to some of our water clients where we have, again, that historic data for 10 plus years. And that's able to help us make better decisions because we understand performance and then we can optimize the performance. So the same thing is analogous to digital twins of other parts and other types of facilities. Walter, you get the next slide as I plug in my headset.
Roger that, guy. Okay, yes. Look, oh man, this is good. Now we'll get into some more of the nuts and bolts of this, the benefits. Right? We talked a lot about, the nuts and bolts of it and the components, right? And what it means and what it is and what it can be used for. But now we reach in some of the benefits of this. And everybody knows the basics of faster decision making. That's what you hear all the time. But look at this, scenario analysis and asset performance management. You see what I mean? You could run scenarios on your physical asset in real time to it's like a model. You perform the model, you see how it's going to operate with different environments, right? You can test those hypotheses. You remember that in statistics courses. Testing hypotheses, get to know, right? Is it going to what is it going to be, type 1, type 2 error? But you can test it and determine what this is going to be. Zero risk environment. You don't have to send anybody out boots on ground and have to go in and and modify the systems and see if they're going to break or how they're going to respond. You see it real time, virtually. More resilient solutions there. It provides those solution set that for the human, it takes a little bit of time to kind of work through the processes to do, but integrated with the right data at the right time and the right amount of it, you can provide a solution set instead of having to do this whole iterative process, right? Then it reduces startup risk and shortens schedule. Risk management is key. Time, cost, risk are key. Those are two components you definitely want to enhance as best as you can. And this, what digital twin benefits is doing, this is what the benefit it provides. And my favorite, optimizing performance. That word optimize is just something about the word, but it optimizes performance of the asset because you can look at that performance and maybe you can adjust it. You can adjust parameters. And those are just some of the benefits. I mean, it can be utilized in different applications, but this is just some of the benefits that we just wanted to discuss with you all today. Thank you.
Yeah, thank you, Walter. And in terms of a digital twin journey, so I think that really helps set the stage from a benefits perspective, and hopefully you've got some more questions about the how and why within your practice and within either the agencies that you support or work for. What can we do to get to digital twins? So like many things, we see this as a journey, and you need to start. We'll start from left to right, and I'm not going to read everything that's on the slide, but you have to understand and establish the business goals and objectives, right? That's similar to many things that we do, is to really understand the mission, right? And as we do that, what's the guiding purpose? What's behind that? How deep do you want to go into digital twins? You don't have to go completely in. You don't have to have that fully optimized approach, that cloud diagram that Walter was showing. You can have parts and pieces. You can still benefit from it, and you can build it over time. What are the insights? What are the metrics? What's the performance? What are you expecting, right? What do you want to gain? Is it do you want to reduce the amount of energy consumption on your base? Do you want to understand water consumption? Do you want to think more about resiliency? Do you want to understand solar as an opportunity, right? How do you manage and monitor that? What technology? To understand the types of tools, whether it's a digital modeling tool or a digital tool that allows you to predict the performance, or is it a sensor? Is it a device? Is it 5G? Is it Internet of Things, right? How do you connect these devices? So what is the technology and what are the tools? Who's going to be your champion, right? Walter, it would be amazing if you said at the end that you're going to continue to champion this within the Air Force. But as I understand, I think you're moving on to your next rotation. So who did you leave this in the hands of, right? And how are they going to take on digital twins within the Air Force? Who is the sponsor, and who's really an executive? And we'll show you an example at the end that shows you where they're actually doing it. Connected data, I referenced this just a second ago with Internet of Things and 5G. What about that big data? How are you going to leverage it? What type of information are you going to gain? Is it at a single installation level? Is it across your entire portfolio? Is it in an area of command, right? How do you understand how those systems and tools are working together, connected trends in many senses? And then how do you enable it? I'm not sure if you said this term before, Walter, and we've used it in the BIM world for a while as a single source of truth, right?
Mm-hmm.
And we added a word to this one, the integrated source of truth. You know, it's pulling from that physical as well as the analytical portions. And then how do you continue to evolve it, right? This isn't the end of the diagram. It keeps going. And there's probably several other points on the future journey. But this is where we've left it within Jacobs as we've tried to describe it to both ourselves and to our clients. Walter?
All right. Yeah, could you say that one
Anything you
more
want to
time?
add there?
I was answering the question in the chat. I messed up, so you don't mind?
Yeah, feel free. If it's relevant to right now, we can unpack it. I haven't seen it yet.
Okay, yeah, this one was, I think we're going to probably touch on it here in a bit. Who owns the digital, it's from Jeff. Who owns the digital twin and who is responsible for ensuring that the digital twin remains current and gets updated when the physical asset is modified?
Yeah, that's a great question. So, I'll answer it very generically based on the slide that's on the screen. I think about it from a purpose standpoint. That's where we would define who the team is, right? Who is responsible? Is it something that you've got a boss contractor doing? Is it a third party that's doing it? Like Jacobs as an example, where we might not have a boss contract, but we are still working closely with facilities management sectors, or is it yourself, right, as the owner and the maintainer? Jacobs has taken on that responsibility. Again, in some of our water portfolio clients where we are essentially running those facilities on behalf of. And so in that respect, we are guiding them through the process and guiding them through the journey to make sure that things are remaining current and understanding what that cycle is for making updates, right? So if you had a new chiller plant that was being put online or an old one that was being deprecated, at what point are you going to turn that into a digital twin? So hopefully that gets close to answering the question. Walter, anything that you wanted to add?
I think you covered it very well. This slide provides that solution set to what you were talking about as far as this journey. But as far as that question, yeah, I would say you're absolutely right. And I think part of this conversation too that we're having with Kurt and myself and the team here is that this whole government industry partnership thing is important. Contractor government partnership is important because where the government may fall short with some of the knowledge base and the skill sets and that ability and tools, the our industry partners can pick up and right where we're having maybe some trouble or some slight difficulties. So I think to answer the question, it just depends. I mean, there could be some strategy in the future to where the government, or in this case DoD, aligns to where they have the ability to maintain these models and update them as necessary, which is what's happening with the BIM, but there's still slightly contracted piece with that. Not that BIM, excuse me, the builder, but it just depends on what that strategy is going to be, and also depends on what that asset is too. Because if it's a strategic critical asset, then you might want more control with the Department of Defense, or in this case, you might want to make sure that you got the authorizations that the personnel needs in order to be modifying or working on that asset. So it just depends on that situation, what the asset is. I mean, it's just a very great question.
Well, and to just touch on the ownership piece, I can't speak 100% clearly to the way that we've done it on the digital twin side, but I can tell you from a BIM perspective, we see that as something that the client, again, if it's defined in our contract language, that it's turned over and they then own in many senses. And I can see that same type of contract language coming through and requiring a digital twin and defining who is the owner at what point, whether it's a transition point from design to construction, to operations to maintenance, or if it's one party that's maintaining it all the way through. So those are still things. I think that's a future. I did not do a search, and I'm going to guess that there's not much information out there in terms of a requirement in the Department of Defense space for digital twins, but that may be a future opportunity to explore. I don't know if that would come through. An example would be the CAD BIM Center of Excellence, or if there's other entities that are really looking into it. So just food for thought as we think about what the continuum of this digital twin journey looks like. Looks like I see another question popping in.
This one is a good one too. From your experience, is there a type of asset or infrastructure that is more in need of leveraging the benefits of a digital twin?
Well, Walter, I'll let you take that because I don't know if we emphasized it enough that your project, your research project, I'll call it that, was focused on digital twins and digital twin implementation. So you dove deep into both the Jacobs practice as well as literature review across the industry in many senses. What did you find, right? What did you find through that, through your research process?
From just looking at the research and kind of just diving into it, I mean, there's a lot of different applications, but I guess for this one in general, like the Department of Defense, I would say or recommend the facility system, maybe mechanical, electrical, the ones that's constantly under maintenance. You're constantly getting calls about maintaining the system, and you're constantly having to put in projects for these systems and your sustainment, using your sustainment funds, right? Or in this case, some of your RM funds too, in order to restore and modernize the systems. This is happening in a lot of the old, dilapidated infrastructure facilities, and even in the water space, right? I know that we have privatized some places, particularly here, right, Pat? Privatized contractor that maintains our water systems on base now, specific parts of it, not the entire system, but specific parts. So, I mean, in those sets, the larger systems that you see are your problem sets for your RIPI, programs, your real property maintenance or your recurring maintenance programs. I would say those would be the type of asset I'm looking at. But on a smaller scale, you could take, any small asset in a facility and just to kind of play with it a little bit to see what type of data. Because I'm saying this now from a standpoint of just doing research on it. And the research indicated a lot of different ideas, and they were using it for like elevator systems, structural beam analysis, right? I mean, this is more like in the weeds of engineering. And I even got a subset in there with the cybersecurity assets within the facilities. So I guess it just depends. But to answer your question, I would look at the system or the infrastructure asset that's causing most concern, that's requiring majority of your resources to either overhaul or repair or sustain. And hope to answer the question. Here's another one that came in too. How do you run the simulations while maintaining the real world replica? Is it a duplication of all data in order to run the simulation space? This is from Joel.
Yeah, so I'll just touch on one thing real quick. From our perspective, we've had a lot of success, and apologize, I was just looking at the video that I've got coming up next, which I'm not going to show, focused on the water side of our business. That's where we've spent the majority of our digital twin effort, is those water clients, those industrial clients, because there's a lot to maintain in those facilities. We're going across market, right? We're looking at applying digital twins in other areas, but that's where we've had a lot of success. And essentially, to tie into that second question is, yeah, we're creating a copy in many senses of the physical assets that are out there, and we can run that scenario testing that Walter mentioned before to understand if we popped in a new pump, right? Or if we changed the way that, again, those water clients are collecting and disseminating water, right? If they change from off hours collection to on hour collection, how does that affect the cost associated with that? The pumping, as an example. So yes, duplication of the data is in order. I mean, you have to have a full system in many senses to make sure that it's optimized. Hopefully that answers that second part of the question that's out there. So with that, Walter, I think there's 2 more slides. Like I said, I'm skipping over the video. It doesn't really show a ton other than a nice screenshot of one of our water projects that had the digital replica enabled. So I'll skip that and then move on to the next one after this. Give me 1 second to pop through that. This one is about our digital twin maturity. So you can see that there's a couple of different paths, and we've got this, I guess, a linear line in many senses, the hindsight, insight, analytics, and foresight, various phases. And, you know, where are we? I've mentioned, and we use this terminology, the replica, a lot. And that's only part of it. Is, you know, we see the digital twin being much more robust than that replica, which is really that simulation model. The digital twin encompasses, you know, real-time data and information and being able to make decisions. And as Joelle asked in the question, you know, potentially can we tweak something real time and see the performance? That's where we're trying to get to. You have to understand the path in many senses, and that's why this is so important. I'm really glad that we've had some questions throughout. We'll certainly take more questions as we get through it. But as we presented this to SAME, I believe for the Facilities Management Conference as a potential, the reason that we wanted to submit the abstract was we wanted to educate. We wanted to share, what does digital twin mean, and what does it mean from a Jacobs perspective, and really glad to have Walter as an objective third party in many senses coming in and doing research side by side with us to say, you know, how could digital twins be applied in the Air Force? It's both a hot topic and the future, right? So it's where we're going to get to, and we really wanted to have the time to share with you. Walter, I do have one other slide. I don't know if you had anything else you wanted to add to this one.
Yeah, I think that you nailed this one too. I mean, the key behind this one, as Kurt says, and then just from the eye visuals here, is just remember that the more you move into that foresight, the decision-making foresight, that's what you're looking at. That you know, that OODA, right? That decision acting part of that loop. The further you get to that, the more you become the digital twin. There's a transition point with analytics, right? And then there's the whole hindsight, 2020, you want to call it that. Part of the replica component, which is, I think sometimes people get mixed up with the replicas and the twins. And there's that transition period where it can be very fuzzy. But just remember, like we said before, decision-making model, that's what it's doing. It's helping you with that foresight, seeing into the future, taking scenarios, making decisions, is helping you with that. Over.
Thanks, Walter. This is the last content slide, and then I've got a resources slide for anybody that wanted some more information. But be a little bit remiss if we didn't mention Tyndall for a few reasons. Jacobs was a partner for the installation of the future. And one of the things that we did, we used models to understand the base infrastructure, right? How are we going to rebuild? How are we going to come back better? Part of what we did is we created a 4-dimensional model, so 3D plus time, one small component of what we could consider a digital twin, because it was, for us, it was a decision-making tool. It helped us understand construction sequence, potential installation, time-space conflicts with, again, an entire base being rebuilt, all new utility infrastructure, some existing infrastructure, but mainly all new coming in, and starting to tag that information through our modeling process. Now, like I said, you could call that a digital twin from a 4-dimensional perspective. It could be much more robust. And one of the things that was showcased in the article that portrayed the link for, and this UAS drone, this flying, was used to capture the base. And so if you haven't read this article, it's a really interesting, just real short overview of how Tyndall continues to use the digital twin innovation. And there's a quote. I couldn't tell, I apologize, from the article who the quote was attributed to, because there were several other sources around this particular paragraph. But this tells you what it will do, right? Provide the foundation for numerous security applications, increase defender situational awareness across the installation, saving time, money, and lives. There we go, there's a quote, I'm sorry. Analyses gained through these digital twin simulations will provide senior level leaders with data and knowledge, again, that data-driven decision making, to make preliminary adjustments before an incident occurs. So this is, again, one recent publication from the Department of Defense space where digital twins are being looked into. And the final slide, Walter, unless you wanted to add anything on here.
I'd say that this is like a premier project here, and it's been going on for a little while now. So Captain Gillette, I think it's Major Select now, opportunity, and myself had opportunity to take a little dive into this to see how they utilize the DT and the innovation here with this project, or with the components of the project. Because I don't know how much folks know about it, but Tyndall Air Force Base took a hit a while back, and now they're looking at how they're going to do the re-infrastructure. Now it's becoming the installation of the future. And there's a lot of key components here, and Jacobs provided quite a bit here with this whole digital twin component, the BIM component too. And I think when it's all said and done, it's going to be something of use, throughout the rest of the Department of Defense. I know others are thinking of some similar, Army, and I think Navy is doing something too with their installations. But this is going to be good, so I wanted to add that, Curtis. Jacobs is doing great work.
And I just want to clarify that Jacobs was not involved in the drone UAS piece, so we're not trying to take credit for that. But it is a great opportunity, and we're happy to continue to support Tyndall as well as other quote unquote installations of the future. And as we are talking to those partners, purveying that digital twins are really the future. And as you do an installation of the future, that's an opportunity for you to focus in on digital twins and then optimizing performance. Final slide is just a series of resources and publications from our Jacobs space. There was a QR code on the first slide that will take you to, again, many deep examples of Jacobs' presence in the digital twin space. Final slide is really just, and for some reason my thank you went away, but I really wanted to thank the audience for their attendance today, and then a link out to, like I said, the site where we have all of the background from a Jacobs perspective posted. With that, I will continue to take further questions. If anybody would like to come off of mute, I would appreciate, we've got about 8 minutes remaining, or feel free to pop questions into the chat and Walter and I can address.
There is one, Kurt, I caught about maybe like 2 minutes ago from Dan Hood. He asked, how did the digital twin save lives?
I'm not sure I understand
the
question.
Yeah, I think I might be able to do this one. It's I guess make sure I understand it clearly, but in I guess the foresight sense. Oh, regarding the Tyndall quote, I got it here. I see it coming in. So it was a Tyndall quote. How did the digital twin save lives? Well, it's got this. Digital twin technology. In this case, they utilize the BIM-2 in this. So you can imagine, and you probably heard this before. I'm gonna tie to this because I know that it ties. The severe weather analysis, the severe weather items that we do now, that's a part of Air Force Civil Engineer Center that's required for all these contracts. The BIM, and I think I don't want to say it was a policy directive came down a couple of years ago too, that was talking about how these facilities will have to be maintained, not maintained, but built for requirements to sustain a certain amount of wind, certain loads, lateral loads, and probably some gravitational loading as well as movement on the ground and water sea rise. So with that, the digital twin technology is a scenario set. So you can run scenarios, you can see how the buildings are going to respond to these different applications, different loadings. And I believe that is where they're going with that quote. I was looking at that whole Tyndall site when it was developed. I believe that's exactly where they're going with that, and understanding like how these different sustainability and severe weather applications are being provided or introduced into this project.
Yeah. So I guess my clarification was I don't think it physically save lives, but it, as it says in the quote, it's projecting, right? It has the opportunity to either help inform pre-alert systems, which may have already been in place, right? When a Cat 5 is coming, you pretty much know that it's coming your way. But for other systems, right, critical systems, being able to know when, where, and how, what's happening. It's that awareness in many senses. So there's another question or comment, right? Using drones to inspect towers, safer use of technology. Absolutely. Yeah. We think about using the right tool for the job, and I'll just get on that soapbox for a second, because really close to what I do from a digital delivery perspective is there are so many tools that are available to our teams today that allow you to keep people out of harm's way. UAS, UAVs, drones are certainly one of them, right? Being able to send a pilot and a spotter down to fly a site, whether it be because it was decimated by natural disaster or to get a better picture of existing conditions. Or sending a laser scanner into a facility that's under construction or being demolished or reconstructed, right? Better use of resources than sending a team of 5 engineers, 10 engineers physically there to map out on a clipboard with tape measures. Again, this is a very antiquated way, or even on tablets and using other digital tools, right? How do you use the right tool for the job to really dive in? And I think what the iPhone 12 released LiDAR sensors as part of the camera. So being able to take what's in your pocket as a person, a consumer, right? Your consumer electronic, take it out, take a picture, get LiDAR, understand the dimensions of a space, much more efficient. Maybe not, probably similar accuracy to if you had a tape out there and you're trying to run it, 45, 50 feet. Anyway, I'll get off that soapbox. Any other questions?
All right, here's one from Joel. As mentioned, BIM is an input for digital twin. What level of BIM is necessary? There is a wide range from 3D to 7D BIM, which is true.
Yeah, one of the things that I didn't talk about was level of development, level of detail, or level of information. And those are all things, I guess it's referenced twice in here. If we go back to kind of this piece, I would say the same thing, is understand the guiding principles, understanding what you're looking to capture, right? And define that in this process. So it's, I'm not going to say it's hard to answer, because you need that physical information, right? You need to understand what the specification of that pump is, how many GPM it's able to push, or what the throughput is, so that you can do that prediction. If you don't have that right level of development, level of detail, then you're not going to be able to do what a digital twin and a digital replica requires to be able to simulate it. So hopefully that kind of touches at a high level on your question there. And again, it's all dependent upon the systems and assets that you're looking to track. If for example, walls, if you only cared about the moving parts, those are the areas that you need to model at a higher level of development, level of detail, 350, 400, 450.
All right, that's good, Kurt. Go ahead, my fault.
No, just see if there are further questions.
Yeah, there are 2 more here. We might have time, depending on how long you want to go, for these last 2 here. With so many asset types, this is from Elena. How is the data consolidated to create the digital twin, assuming asset details come from different platforms?
Yeah, great question. That's one of the things as a as a model manager in many senses that we look after on a day-to-day basis, right? So it's understanding those systems first and how they work together, what that authoring platform is and how they work together. Is there a way to extract the information that is aligned with, like I said, performance? Again, back to the pump example, how many gallons per minute, right? Are there standard criteria that you've defined? And all that needs to be defined up front so that you can get into those insights in many senses. So again, I know that's not a direct answer, but it's understanding what capabilities that the tools have that you're using, and then what fields are important that you need to track.
Right. Yeah, that's all good points. I mean, yeah, all those are definitely good points. There's one more question I think we can entertain. I might can answer this one here from Mr. Trevor Clark. It seems a lot of emphasis is placed on the data from design phase and the operation and maintenance phase. But is data captured during the construction phase saved or used in the digital twin? Yes, I'd say that I'll use BIM, especially and particularly with this probably this Tyndall component and maybe another one like it. So they're utilizing the BIM as a construction piece that go to at the construction schedule cost building piece that they utilize as they're going through the processes of putting that facility together. And so as things are changing, as builds are changing, or drawings are changing within the subset, whatever those field changes are, engineering, construction changes, whatever those changes are, my assumption, and Kirk can add to this, how the BIM works is that they'll be able to input this data in this collaborative environment and update those drawings as necessary as they're walking through the facility construction installation phase. And if you utilize it in that sense, I think it answers the question. But Kurt, if you have anything else to add in that regard.
Yeah, I think Walter, high level and summary level, that's pretty darn close. What I would offer up is Elena and Eddie, we're working on a project right now where that is exactly what we're trying to get to, is taking models from the contractors, taking content from the contractors, taking laser scan data from the contractors, and integrating it back into the digital twin, which will feed into the client's computerized maintenance management system. And we can't share the details yet, but we're really excited about what the potential opportunities are there for this particular client that is a major facility manager in many senses, and how that plays across portfolio from a campus perspective, right? Because the project that we're talking about is a campus project, many facilities. It doesn't have to be, but we're excited about what we're seeing there. We just haven't been approved to release those details yet. If I was, I would have shown that slide and talked in detail about that process. So maybe you'll invite us back at some point in the future. So Eddie, I see you've come on, and it looks like we're over time.
Yes, thank you. Elena, any closing words? A great presentation, a lot of good information there. So thank you to you both. Elena, any closing words?
No, I was just going to wrap it up. Thanks everyone for joining this webinar and for the great questions. To Kurt and Walter, thank you for your time and presenting and talking about your expertise in digital twins. For those that, if anybody has knows somebody that wants to watch this recording, please let them know that it'll be available on the Young Professional COI page on the SAME website. We'll also upload the PDH form for anyone who needs it. But yeah, that was a great webinar. And again, thanks for your time. And yeah, we'll talk soon.
Well, thanks for the opportunity, and thanks to Walter for allowing us to feature his work as an EWE fellow with us. And I'm glad to have you, hopefully as a neighbor here in the DC area not too long from now.
Definitely so, probably in the next week or so. But thanks again to you too, Kurt and Elena and Eddie, for running this SAME program for the young professionals. This really means a lot. I mean, it's really hard hitting, a lot of good data, a lot of information here. Even though we high serviced it, But if there's any other questions, you can always reach out. I mean, I think this whole educational industry or industry and government partnership is the future, or at least moving toward that way. And the better we can nurture these relationships, I think the better we'll be off as far as national defense is concerned.
Thanks all.
Yeah. Take care.
Bye, everyone. Thank you.